earlier in the year, we talked about our parent graphs, if you remember, and we talked about like square root of x, 1 over x, all that sort of stuff. Sorry for those who can't see. Our graph I'm going to do right now is f of x equals 1 over x.
Wait, can you say that question?
Asymptote. Now I'm going to tell this joke here right now, and the internet's hearing this, and if Reed Snyder is listening to this, he will agree with this. He said when I taught this lesson to him, 5 or 6 years ago, he went home last. He was all excited by the word asymptote. He was very excited by it. So he went home and he called his sister an asymptote. And he got, what's it called? What do the parents do to kids? Ground is the word I'm looking for. Yes, he got grounded apparently for a week. All right, so go home tonight. Do not call your younger or older, in your case, name. Don't call your brother an asymptote. He will know what it means. No, don't do that. Don't do that. Okay. So here we go. There's fx 1 over x. I'll show you what an asymptote is, what it looks like. What's that? So here we go. So here's the graph right here of 1 over x. Okay. If you remember, we did this earlier in the year. There's my x. There's my y. 1 over x is going to look something like this. Okay, so what an asymptote is, it's a dotted line that the graph comes close to and doesn't touch. So if you take a look here, along the x-axis there, neither of those lines is actually going to hit it. If this line were to continue off, the red line, it would go to the right along the board like this forever and ever and ever, but not actually cross that line. In the same way, there's a vertical asymptote up and down, and I do all my asymptotes with dotted lines. It goes up and down like that, but the graph's going to come close to and not touch. Now let's try and get how I get those asymptotes, because are we have questions so far? Please ask, guys. I know this is a new concept for most of the class here. Okay. All we're saying, the asymptote's going to come close to and not touch. We're good? Now I'm going to show you where those come from. Go ahead.
So the red line is an asymptote?
No, the red line, this is the actual graph of 1 over x. Okay, so this right here is 1 over x. Is this.
Then what's the point of an asymptote?
The asymptote just shows where the graph can't cross. Okay, so let's just start here with restrictions. What's my restriction on x for that graph? Sorry? X can't equal 0. Now where this is leading to is this asymptote is conveniently x can't be 0. Okay? So an asymptote is actually a restriction is an asymptote on the graph. Okay, are we okay on that logic so far, right? Yeah. Asymptote's a dotted line that it can't cross. It's a dotted line, but it's like it's a wall that you can't get through. Okay, unless you're James Bond or one of those. You guys see that James Bond movie where he ran through a wall? That was awesome. Anyway, if you haven't seen it, see it. It's a good one. Anyway, this other asymptote right here. For this one right here, this asymptote as well is going to be y can't equal 0. Okay, this one right here always exists. Because is there a way that I can make that equation the right-hand side equal to 0? Well, it's impossible, right? Let's say I just use some algebra. Let's multiply both sides by x. I get 0 equals 1, which can't happen, right? It's impossible to have them to work out. So because this can't happen, we're going to say that that asymptote's not going to work right there. So that's where two asymptotes come from. Okay? The way we actually get that graph, if you're interested, and I know you are, David, okay, is we can pick different values, okay? So I'm going to actually make a quick table of values. This will be a very, very fast one. And after this, we're going to do this again. So I'm going to do x and 1 over x. And do a point. Okay, that's a giant table of values. But I want to get the idea of the shape of this. So what I'm doing is I'm just picking random x values from -10 to 10. I know how this is going to look, so I'm going to maybe throw a few more at the end. Okay, I would like plenty of volunteers. Lily, is it your birthday today? Happy birthday, by the way. Lily, since it's your birthday, you can do the first question for me. If x is equal to -10, what is 1 over x then, please? 1 over -10. For the first time ever in my life, no, I don't want to get -1 over. I was going to go to a decimal, but let's not. -3. Okay, keep going, yeah. Yeah, -1 over -3 or -3. Okay, so -3 and -1. Right? So it's still a little small value. -2 is going to be -1 over 2. -1 is going to be? Yeah, -1. And -0.5 is? Equals? Yeah, -2, but yes. Now let's just show you what we found here. That's a -2 we said, right? What I actually just found there was -10 is over here and 1/10. -3 is here, -1/3, 1/2, 1, and then -2 down to here. Let's say we pick a value like -0.1, being really close. What's my y value going to be when x is -0.1? Okay, so we help me here. Stay awake here. Vanessa, what's it going to be? If x is -0.1, what's y going to be? Oh, come on, guys, stay awake. This is going to be a very painful lesson. What's 1 divided by 0.1? Anybody here? Not just you, I'm not just asking you, I'm going to get everyone here. What's 1 divided by 0.1? Thank you, okay? So the point is here that if I do this as -0.1, you get 10, okay? If I go 0.001, so I'm getting closer, okay, what do I get? 100. If I go, let's even go crazy, 0.001, what do I get? 1,000, okay? The point is, as you get closer and closer to this line, you're getting smaller and smaller and smaller. That's the point I'm trying to make here. We're good? Yes? Okay. Let's say I were to get to 0, what would my answer be? You can't, but what would the answer be if you're following this pattern? 100, 1,000, what's going to be the biggest negative number you can get to? Infinity, or negative infinity. That's what it's going to be. Infinity is not a natural number, it's a concept. And I tell a joke right now because my daughter loves to count just like I used to when I was a kid. Infinity came to me when I was 2 years old. Okay, because the count said to a little boy or girl, I can't believe I'm going to do my count voice, but I'm going to. They said, what's the biggest number you can think of? And the little girl goes, 8. And the count goes, add 1 to it. And she goes, oh, 9. So I thought to myself, I thought, what is the biggest number? 19, 20, okay, 99, 100, 999. I don't know if I do that number. But the point is there, right? There's a number, infinity is just the concept, the biggest possible number you could ever come up with. That's what that is, okay? So we can't actually get to 0, but if we could, it would be a negative infinity. Okay? The problem is we're going to go the other way, and the same thing is going to happen, but in reverse. So 0 right now is going to be error. 0.5 is going to go to 2, 1, 1/2, 1/3, and then 1/10. This is what is 0.5, 2, 1, 1, 2, 1/2, 3, 1/3, and 10, 1/10. So they did the same thing. As you get closer to 0, it's going to get closer towards infinity. As you get further away from 0, it's going to get closer to 0. Okay? So the point is, and this is where the restriction or the asymptote comes in, because if you're going to 0 on this side, you're going to negative infinity. If you're going to 0 from this side, you're going to get positive infinity. There's a problem when you get to 0. Right? Is it positive or negative infinity? No one knows. And don't let yourself freak out. If you ever see me staring off in space like this, it's because I'm trying to decide whether I'm at negative infinity or positive infinity. It's a true question. All right, I'm going to hit pause in the video right now and let you think about that, and then we'll come back to the actual graph. Are we okay on the concept of asymptotes, though? Okay, we're okay why the graph looks this way, because I just before threw that up there. But the idea of the points are, as you're getting closer to 0, you're getting a bigger value or a smaller value. And again, if you're getting further away, it's heading towards 0. We get the logic of that? No comment means good. Okay.